Hello, welcome to a video for section 2.2. We're going to be talking more about transformations of graphs, more specifically for parabolas or y equals x squared. So I'm going to go through the first 3 pages, I believe, of these notes. And I'll ask you guys to pause the video from time to time and work with your table group members. And then, of course, go back and watch and fill out more of the notes. And by the time we're done with the notes, you should have plenty of time in class to work on homework, which is right here, homework number 14. And if you want to do extra practice problems, there are more extra practice problems on the last page. And if you're C period, you should have these notes already. I have extra copies on my desk, which your sub can hand to you. If you're D period, I forgot to hand this out to you, so your sub will give this out to you during D period. So let's look at 215A. Ms. Polyparabola is very impressed with the work you did previously. She wants you to create your own fancy parabola and show how you can change your equations created. I don't think there's really much to do with part A. I'm a little confused by what you're asked to do. So let's just cross that one off. That one just seems a little strange to me. I'm not sure what we really need to do for that one. I mean, yeah, obviously we want to draw a parabola. There's a parabola, right? Where we call this H and K. That's the vertex. And you have a random point here, which we call x, y. And you want the equation in terms of x and y. And remember, A that we'll use in our equation will determine the stretch or compression. Also tell you if you have to reflect. And this will lead us to part B. Because part B is asking to write a general equation for the parabola, so it could be shift or stretch in any direction by any amount. So the way we write this, we talked about this in the last class, would be like this. So part B, I clearly know what they want us to do. Part A, I just kind of improvised there. I just drew a general parabola. H in case this is the vertex, x and y is some random point on the parabola. A is going to be part of the equation, which goes in front. But part B, that's what we need to do. Now we're going to use part B to help us answer the next question, 230. Let's move on to 230. So let me go ahead and erase some of the other stuff here first. And let me keep this right here and kind of position it a little bit like that. Here we go. Actually position it again. Perfect. Okay. So now you got your general equation, which is right there. And remember, H is a horizontal shift. K is the vertical shift. And A is for vertically compressing or stretching the graph. And it's also responsible for reflection about the x-axis. That will happen when A is negative, by the way. So the first bullet point is asking us to identify which parameter affects orientation, vertical shift, horizontal shift, vertical compression, blah, 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 for y equals x squared. So that's what we're going to do down below. What values stretch the graph vertically, compress the graph vertically? Why do those values have these impacts? So we know that's going to be A. So to stretch it, that's when A is bigger than 1. To compress it, that's when A is between 0 and 1. And why does it do it? It's not, and you want to be careful, it's not like slope. It's not exactly slope, but it's kind of like slope. So when A is bigger than 1, the graph is more steep. When it's between 0 and 1, the graph is less steep. So let's go to Desmos. Let's pull it up here. Here we go. So y equals x raised to the second power. And let me clear the screen for a moment. And then here you got y equals 2x squared. And the blue curve is definitely more steep. Now, if I were to make a table for y equals x squared, pretty simple, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Now, if I make a table for the other curve, I'll do in blue. Now, if I plug in 0, I still get 0. If I plug in 1, now I get 2, because you got to use PEMDAS. 2 times 1 squared, of course, is 2 times 1, which of course is 2. Plug in negative 1, I still get 2. Plug in negative 2, now I get 8. And plug in 2, I get 8. And actually, let me be a little more consistent. We'll do 2 first, 8, negative 2, 8. Okay, cool. Well, what we've done is because you have the 2 being multiplied x squared, you multiply every y coordinate in the original table by 2. So that's what you do when whatever a is what you multiply to y. And that's why the graph stretches vertically, because you're multiplying a number larger than 1 to all the y coordinates from the original graph. This was the original graph, y equals x squared, or the parent function. By putting a 2 there, all the y values get multiplied by 2. So going back to the notes, why do those values have these impacts? Because you're multiplying y coordinates of the parent graph by the letter a. That's hard to read. Let me put it down here. So that's what has those impacts. And again, when a is bigger than 1, stretches vertically. When a is between 0 and 1, it compresses it. And if I go back to Desmos again, see if I put like, say, 1/2. So it's not increasing as quickly. So it's less steep as a result. Okay. Now, what causes the graph to flip vertically? We know that's when a is negative. A little bit unsophisticated to say that. I much prefer you say reflect about the x-axis, but of course, flipping vertically probably makes it more visual, easier for you guys to figure out what's going on. And yeah, it's kind of the same thing. The y has an impact because you're multiplying the y coordinates, or you're changing the sign of the y coordinates. So that's why it does that. Now, what causes the graph to shift to the left or to the right? To shift to the left is when h is negative. To shift to the right when h is positive. So let's go to Desmos and look at that really quickly. So y equals x squared. So if I put parentheses, do x plus 1. Now in this case, h is actually negative 1 here. Even though you see a plus 1, h is negative 1 here. And why does it go to the left? Because if you think about the original table, x and y, 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. Now over here, if I want all the same y coordinates as the parent function, I have to take 1 away. From all the x coordinates on the parent function. So now if I plug in negative 1, I get 0. Plug in 0, I get 1. And plug in 1, I get 4. And if I plug in negative 2, I still get 1. If I plug in negative 3, now I get back to 4. So you have to take away 1 from each of those. So you see x plus 1, but remember, we assume the form x minus h squared. So when h is -1, that's when we get x minus -1 makes it plus 1. So when that happens, we go left 1. So that causes the graph to move horizontally because you're taking 1 away from all the x coordinates. Because in order to get the same y values, you have to take 1 away from the x coordinates to guarantee the same outputs. So let me actually close the text box. To get the same outputs as the parent function, remember the parent function is y equals x squared, y equals x squared, we must take away 1 from the x coordinates. When the equation changes y equals x plus 1 squared. And then you kind of do, kind of see the opposite effect if you do x minus 1. Now in this case, we're adding 1, where h is not positive 1. Even if you have minus 1, you assume the form x minus h squared, so now h is 1, but you see x minus 1. So in this case, h is positive again. Now we're adding 1 in order to guarantee the same guarantee the same output. So again, the parent function is this 0, 1, 2, 4, -1, 1, -2, 4. So you have to add 1 to guarantee the same outputs. So 1, 2, 3, 0, and -1. So that's what's happening there. And again, if you plug those in, so in this case, you have to add 1 to the x coordinates when the equation changes to x minus 1 squared. So that's what's happening there. So going back to notes again. What causes the graph to move left? When h is negative, to right when h is positive. Why? Because let's add or subtract the x coordinates of the parent function to guarantee the same output values. Now, up or down, this is when k is positive or when k is negative. And in this case, what you're doing, I need a little more space here, is you're adding or subtracting a value to y. So if you're adding 1, the graph goes up 1. If you're subtracting 1, the graph goes down 1. And if we could take a look at that in Desmos, x raised to the second power, so plus 1, up 1, minus 1, down 1, down 2, we're up 2, we're up 3, we're up 4. So you're if you go back to the table again, and you probably have, so you don't have to write it again. But again, this is for the parent functions. This is 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. If you have a plus k value, or let's just go back to say plus 1. Here we go. So you have to add 1 to all the, you have to add 1 to all these. So you keep the x values the same, but now you're adding 1 to all the all the y coordinates. So that's why we see a shift up. And then the last little point, are there points on your graph that connect to specific parameters? Totally. The vertex correspond to H and K. 100% it does. Because again, our general equation was this, right? The vertex, because the vertex initially is at 0, 0, and we move right H and up K, or whatever, or left H, down K, or a combination of that, the vertex will be H comma K. I think that's all there really is to it in terms of the parameters A, H, and K. I don't think that corresponds to anything else on the graph necessarily. You might want to be careful to how you label A or corresponding a point on the graph to A, because if you move the graph left right, it does get a little confusing. But I think vertex H and K, I think that makes a lot of sense. So, okay. So here's where you guys are going to now pause the video very shortly and do some work in your groups. So here you have to do three things: predict the coordinates of the vertex, find the orientation, meaning if it opens up or down, and if there'll be a stretch or a compression. And do not use a calculator, not use Desmos or TI-84 calculators. Make a try to make an accurate graph based on your predictions. Now you can make a shape your graph after without using a table. I'll talk about that too. So let me do kind of the more complicated one. Let me do F. Now the guys do A through E. F is 2 parentheses X plus 3 squared minus 8. Let me write that down. Y equals 2 parentheses X plus 3 squared minus 8. My short-term memory really stinks. Let me make sure I got that right. Cool, I did. Okay. So remember, the general formula is this: Y equals A X minus 8 squared plus K. Your A is 2. Your H is -3. And your K is -8. So the vertex is easy. Without doing the graphic, so now I know the vertex is H and K. Right, so you get -3, -8. Again, H goes left and K goes right. The vertex is at 0, 0. You went 3 left and 8 down. The vertex is at -3, -8. So remember, Y equals X squared is this. So by going 3 left and 8 down, we're like this. The clear vertex is right there. And it does open up. It's because A is positive, or A is 2. And it stretches by a factor of 2. So how did you do an accurate graph? Here's what you do. So I draw my vertex. Like this. And then, because A is 2, it's not a slope, mind you, it's not a slope. But what you could do is you go 2 up and 1 right, and 2 up and 1 left. That'll work for us, because if I were to plug in, say, -2, -2 plus 3 is 1. 1 squared's, of course, 1. 2 times 1 is 2. 2 minus 8 is -6. So now I'm going to go up 2 over 1. And likewise the other way, up 2 and left 1. Because if I were to plug in -4 plus 3 is -1. -1 squares 1. 2 times 1 minus 8 is -6 again. So see, I'm going up 2, right 1. I know it's kind of hard. I didn't do the best job drawing tick marks. But you can think of like slope, only when you're going 1 to the right or 1 to the left. And that's to do a quick, accurate graph. That's how A would help you. So it's kind of like slope, but not exactly. Because if you try doing that for a point further away, it won't make sense, because you're not doing up lines. But for 1 away, 1 right, 1 left in the vertex, you totally can do that. It'll work just fine for you. So now I've done part F. In your table groups, go and pause the video and do A, B, C, D, E. Now I'm not going to work those out in the video because it makes the video really long. What I will do is I'll actually print this at home and put the answer key to the notes in Schoology. Actually, if you go to Schoology, I'll show you where I'll keep it. Oh, geez, that's right. Yeah, if you go to Unit 3 in the clear screen, and if you go classwork and homework files, I'll put it right below. I'll say Algebra 2, CW, and HW 2.2, and then print up the solution key. So you can check your work after you do this in your groups. But please, no cheating. Do A, B, C, D, E in your table groups. I imagine you probably need about 5 to 6 minutes, maybe longer to do this. When you're done, you can go back and play the video again. Okay, last part of the video, 232. So hopefully by now you've finished all 231, A, B, C, D, E, and check your work in Schoology. Make sure you got the vertex, whether it opens up or down, and whether it stretches or compresses, and then try to make an accurate graph table. Let's do 232. So y equals, gonna hide that. Let's try it again. There we go. Y equals 2x squared plus 4x minus 30. So what's orientation? It's clearly going to be up because your leading coefficient is 2, which of course is positive, right? So even though it's not in vertex form, so vertex form, remember, was if y equals a, x minus h squared plus k. That's what we've been working with for now. This is actually called standard form. For standard form is y equals ax squared plus bx plus c. But the a value is still the same for both forms. And your a value is 2, so it's opening up. How do you change equation make it open the opposite way? Make it negative 2. So change a to a negative number. You can make it negative if you want to. If the function vertical is stretched or compressed, it's going to be stretched, and the factor is still 2. So it still stays the same. In fact, actually, what if I have y equals 2x minus 1 squared plus 1? You don't have to write this down, by the way. But if I were to expand this and combine like terms, you have 2x squared minus 2x plus 1 plus 1 on the outside, 2x squared minus 4x plus 3. So it's still the same thing, right? The a value still stays the same. Now, can I identify the vertex from the equation? Not really. Because I don't know if it moves left or right or up or down. It's hard to tell right now. I do know the y-intercept's negative 30, by the way. If I plug in 0 for x, the y-intercept's negative 30. I know that. But still doesn't tell me enough in the way that it's written. That's why vertex form is a little more powerful. It gives you more revealing about the equation and how the graph will be. But I know the y-intercept's negative 30, plug in 0 for x. But right now, I can't really identify the vertex from the equation from the way it's written. But what I can do, let me zoom out a tad. It's like a factory equation. Get the x-intercept. So we've done these already. So how do I find the x-intercept? So I can factor out 2, x squared plus 2x minus 15. If I continue factoring it, if you need to do the diamond, go ahead. Negative 15 up top, 2 down below. That'll be 5 and negative 3. So you have x plus 5, x minus 3. So the x-intercepts are negative 5 and 3. Because they make those 0. They make the equation 0 when you set equal to y. Then replace y with 0. So now I know where it crosses the x-axis. 1, 2, 3, 4, 5. 1, 2, 3. So I suspect the graph will look kind of like this, where it crosses the y-axis at negative 30, right? That's y-intercept, and that's negative 5 and 3. So we got to think symmetry, right? Symmetry is halfway between those x-intercepts. Well, it's pretty clear. Oh, I'm off a little bit, my bad. The axiom is x equals 1. Nope, sorry, y negative 1. So where's the vertex related to the x-intercepts? Halfway between. Halfway between the x-intercepts. So what you could do is you could average the x-intercepts. Negative 5 plus 3 divided by 2, negative 2 of 2. Bingo, you get negative 1. So now I know the x-coordinate vertex is negative 1. But I don't know the y-coordinate. So use x-coordinate to find the y-coordinate. So you can plug in negative 1 into your equation. You can plug into the way it was originally or into the factored form, totally up to you. But plug into the original standard form. I should get 2 minus 4 minus 30. Should get negative 32. Yep, negative 32. So negative 1 comma 32. Negative 32. And I graph it. I already have the graph done, so I don't have to do much more. The graph is already taken care of. So I have the x-intercepts, I have the vertex, we're all set. And now I can write the equation in vertex form. So I fully analyze this. So I know, ooh, that's not a word. So I know that it's y equals a x plus 1 squared minus 32. Remember, the vertex is at negative 1, negative 32, right? And again, it's got to kind of look like this. Cross at negative 5, cross at 3, vertex is right there. So how do you figure out what a is? You can take one of the x-intercepts, let's say I take 3, 0, replace y with 0, and replace a with 3, and you solve for x. If you do that correctly, 0 equals 16a minus 32. 32 equals 16a. A is 2. So the equation will be y equals 2. So you can't use slope exactly. Even though I said, even though it's slope, when you go 1 away from the vertex, 1 to the left, 1 to the right. But when you have a point that's pretty far away, like 3, 0, negative 5, 0 from the vertex, you need to plug in the coordinates of that point into x and y to the equation to solve for a, just like we did for exponential functions. When we figure out what b was, we have to solve for a. So there we go. That completes this lesson. So you got some homework. Homework is down below. I will post the solution key for homework also in the same place in Schoology. What I'll do is I'll make one file called Algebra 2 CW and HW 2.2 parentheses solution key where I'll have it filled out for the notes, and also I'll have screenshots of the answers for the homework so you can check your work in case you get stuck. If you are CP, you have Mr. Davidson's your sub, who teaches math, so you can ask him for help. Ms. Wrench, she's a history teacher. You may have had her for history. I don't think she'll be able to help you with the math, but you know, you definitely have each other help, you know, to get some guidance. So anyway, so yeah, so the homework is right here. Go through it if you want to do extra practice right there. I'll put those answers here for the extra practice, and that concludes the video. All right, and I will see you guys. CPRO see you on Thursday, and DPRO see you on Friday morning. All right, have a good one, guys.